Hey coders, welcome back. In this video, I'm again going to take one of the questions from on-site interview. So if you don't know me, I generally solve questions from this assessment section where you can select online assessment, phone interview one or on-site one, and you will be getting like random two, three questions that you can solve as a real-time practice. So my videos are like totally unscripted and totally unedited. So it's simply all my thought process, how I'm approaching my questions, everything will be real, nothing altered, right? So in my last two videos, I taken this one, phone interview one, and the online assessment one. In this video, I'm going to take this on-site interview one. So I think it consists of three questions, one easy, one medium, and one hard. I will, if the hard one is too tough, I will try to avoid it because generally I mean, apart from the OA, you don't get harder questions because you have to solve and explain the questions in like 20, 30 minutes. So, and getting harder question doesn't make sense, right? So yeah, in this video, let's go this on-site one and see. So it says like if we have four questions and 2 hours to complete. You cannot pause it, cannot stop it, right? So let's start. Let's see what question I'm gonna get, and let's try to solve this. So yeah, there we go. So here, if my screen is visible at the below side, I don't think it is visible, but there are four questions. So this is the first one. Okay, so you can see at the top, no, right? Yeah, here at the top you can see we have one, two, three, four questions. Uh, Yeah, so let's try to go through each one by one and let's see. So this is the easy one, I think. So given a string S, we have to reverse the order of words. Okay. A word is defined by this. Return a string of words in a reverse order, concatenated by a single space. Okay. And note that S may contain leading or trailing zeros or multiple spaces between two words. The return string should only have a single space separating the words. Do not include any extra space. Okay, so we have to go each word, each sentence, word by word. There may be different spaces, so we have to make sure. And then we're gonna just take like hello and then world, we're gonna reverse it, world and hello. And we have to make sure we are removing the trailing, this trailing spaces, right? So let's first I will remove the trailing spaces from start and end. So this string method will do that for me, right? And then what I'm gonna do now, I'm gonna split each word based on a space. So I can say maybe string of word equals to s dot split based on space. So we get the words space by space. And then what I'm gonna do is I'm gonna uh, create a list of string maybe list new. There it is. You can try to avoid these extra variables, but it makes uh, code much more cleaner and readable, and it does not affect time complexity a lot. So yeah. So now let's iterate over each word. Um, I can say A, F, W. I should take some good names, but yeah, let's go with this for now. So for each word, first I have to trim it, right? From it, it might contain some spaces. So I have to trim it. So what I'm gonna do, I will say list dot add, or maybe I can say like age equals to a dot trim, and then if a dot length is greater than zero, oops, a dot length greater than zero, then I'm gonna add this into my list, right? So list dot a. Sorry. So yeah, and now I'm need to reverse this list. So we have something called collection dot reverse list. You can write your own reverse method. It's not rocket science, just two pointers and then you can swap it. But yeah, for now, I think we are good for this one. And now we have to convert this list in a string. So I can use Java stream for that. So list dot stream dot collect. And then I have, I think, collectors. I hope these imports are already imported by LeetCode. The collector dot joining by express page. And then we can say return. Okay, now here string answer equals to this answer dot trim again because I might have added extra white spaces in the last, right? So let's start to trim dot collect collectors dot joining. I think this is correct. Let's try to run it and see. And do we have any compile time error or not? Okay, so we don't have. Blue edge sky. I think I'm getting the correct result. Let's try to see if we have s can be null or anything. No, s length will always be at least one. So this trim method will not throw any null pointer exception. So that's good. And yeah, apart from this, nothing. Let's try submitting it. Yeah, it is submitted. Uh, do I have to explain anything here important? No. Uh, yeah, I think we are good. Right. You can think of this. Yeah, this might be different. So you, if you're not comfortable with the stream, you can just go each word by word, and then maybe using string builder, you can keep appending it, and then return the string builder and in the string form using toString. You should use string builder because you don't want to create a new string, right, for every concatenation. So that will be more efficient. But for now, I think this is good. So let's move to the next question. Mhm. So this is a binary tree based question, looks like. So find the lowest common ancestor of the two given nodes in the tree. So if you don't know the LCA, so let me explain the idea of LCA. So for LCA, you choose any two nodes, right? So let's say for in this tree, the very first tree, if I choose 6 and 8, so what is the lowest common ancestor? So I just need to check where this is the meeting for the first time. So 6 parent is 5, 5 parent is 3, okay. 8 parent is 1, 1 parent is 3. So 3 will be the meeting point, right? So in this case, in the example, if you see p is equals to 5, q is equals to 1, so 5 and 1, so who is direct parent? 3, right? So this is correct. Let's go to the example 2. Here it says like p is equals to 5, q is equals to 4. So p is equals to 5, q is equals to 4. And then if they are in the same branch, so that here it will be 5, right? So 5 will be the parent of 5 and 5 will be the parent for 4 also. So kind of same. Like if it is in the same tree, so the node which is higher, that will be our LCA. And if you see the constraint, it says like 10 to the power 5 means you have to solve the question in a linear time, right? So what's the idea? Idea in most of the tree-based questions, if you're comfortable with DFS, you can tackle it, right? And there are advanced concepts also for finding LCA-based problem in a constant time. So basically, there is something called binary uplifting, tree uplifting, binary uplifting. I don't exactly remember, but how we do is we simply pre-process the nodes, right? And after pre-processing, since here we are also getting this P and Q, right? Right, the node 5 and 1, we need to find the ancestor. If this is like a queries, right, so then we have to write some efficient algorithm. So binary lifting is there. If you wanted to search, you can search it. But for this question, since we only have to find for one particular set of nodes, linear will be perfectly fine. So what's the idea to solve this? The idea will be, so let's see for this node, let's say for 5 and 0. Okay, let's no, let's take for 5 and 1, right? 5 and 1. So we try to find 5 or 1 from the, so this is the root, right? 3 is the root. We try to find 5 from the left side, or 5 or 1 from the left side, 5 or 1 from the right side. So when I get this recursive call, no? So do I have 5 or 1 in the left side? Yes, we have. So it will return something. And from the right side, do we have 5 or 1? Yes, we have, right? So for this node, we are getting some output that is not null. And for this node, also we have 5 or 1, 5 or 1. It means those two nodes are exist just right side and left side of this root node. So this root node will be the answer. Meaning, so there will be two or three conditions. We will say I'm able to code it. So let me explain one more example, maybe this one, the 5 and 4 one. So here you see in example 2. So we call a left call from the 5, right? Do we have 5 or 4 anywhere? No, in the left side we don't have 5, we don't have 4. And from 5 we're gonna call, do we have 5 or 4 from here? So I'm gonna say no, we don't have 5, but we have 4, right? So we're gonna return, and then based on condition, if left is a null and right is not null, so of course this will be my LCA. So that's the idea. You can do a simple DFS for such question. So let me try writing the solution for this, and then we can discuss more maybe. So I will do something like return DFS root P and Q. I think this I can use this method also, but just for simplicity, I don't want it to type lowest comma ancestor bunch of time. This is so long, so I'm just calling a helper method DFS, and I'm passing this root P and Q, right? Same method. Let's, and then the idea is the same that we discussed. DFS tree node root, and then tree node P, and then tree node Q. Uh, okay, yeah. So what's the idea? So I will say go and try to find something in the left side, right? In your left subtree, and I will same say try to find something either P or Q. Can you check? I'm saying this TFS method. Can you check in your right side? Do we have any P or Q or not? Right. So this is the calls, right? Okay. Then I'm gonna say if left equals to not equals to null and right is not equals to null. So the case one here, this example one, I will call 5 in the left side. I will call one left call in the left side, right call in the right side. So this will return 5. This will return 1, right? Because 5 is there and 1 is there. And if this is the case, so what will be my answer? My answer will be the root, right? So I can simply say return root. This is the first condition. What's the second condition? We might have uh, something maybe only in the left side, right? So I can say something like if root is not equals to null, this means, sorry, not root, left. If left is not equals to null, this means we have something in the left side, right? We have something from the left side, so we're gonna return left. Okay, my battery is down, but okay, I think we will be good. Else, if right is not equals to null, this means return the right. Else return null. Okay, so this is the idea. So what I'm saying, so for this, I think the first condition is pretty clear. If left side is not null and right side is also not null, so it means we have P and Q in the both sides. So we can just return the root, correct? Now, for example 2, when I this 3 will call this na 5, left child and right child. So this right side will come as a null, okay? And left side will not come as a null. So whatever answer returned by the left will be my answer. So that's why I'm returning left. Similarly for right side, and similarly if nothing. So for example, if you see here in this tree, at the root node, at the node, let's say 2, right? We're gonna call left call and right call. We don't have 5 here or 4 here. We don't have, sorry, not this one. Let's take this one, 1 1, node 1 1. So here in the left side, we don't have 5 or 4. We don't have 5 or 4 in the right side. So this will return null, right? Because it basically it means it didn't able to find any answer at all, right? And when I'm gonna stop? Well, when root is equals to null, I can simply return null. So yeah, this is my base case. I hope this is clear. Let's try run it and see if we have any compile time error or are we getting exact answer or not. Um, okay, I'm getting null. So why I'm getting null is, so left is not equals to null and right is not equals to null. I'm returning the root, right? And if left is not equals to null, instead of doing this, I should do something like left equals to null, then return right. One second. I'm missing some conditions maybe. So if both are not null, and that's the happy case, very good. Or we can have something like if both are null, right? So can do something like this. If else if left equals to null and then right equals to null, we can simply return null. Else if left equals to null, return right, else return left. So I think these will be the all conditions, right? So either there will be no null or there will be both of them are null. And if left is equal, if you are able to proceed from this condition, this means and left is equals to null. This simply means right is not null, right? So we're gonna return right, else we're gonna return left. Let's try again. Okay, I'm again getting null. What I'm missing? Oh, my base case. Oh my god. Sorry guys. So this is good. And whenever we able to match, if root equals to p or root equals to q, I have to return root now. So I'm saying, so either so whenever I'm able to find one node, right? So for here example one, I'm getting a call in the left side at the 5 and 5 is equals to 5, right? So this node is equals to this node. So I'm gonna return this 5 to the my parent. And I was missing this condition. And yeah, I think the rest of them is good. Let me try again. Okay, I'm getting 3 now. And let's try submitting it. Yeah, I'm able to submit. So I hope this is clear. It's a recursion. If you draw this logic using pen and paper, it will be easier to understand. But I think you know the core idea, right? And of course, if you wanted to go one level above, you can try understanding binary lifting. There are bunch of different articles uh, there you can choose from and then try to understand. It's pretty intuitive and it's pretty cool. It can basically find the ancestor of a node, two nodes in a constant time. So for a query-based problem where let's say you have n queries and in each query you need to find like what is the LCA for 6.2, what is the LCA for 4.0, what is LCA for 4.2. So that will help you to understand much better this problem. So yeah, for now, let's move on to the next question. Question 3. So this is a matrix-based problem, and I don't like matrix to be honest. So it says like write an efficient algorithm that searches for a value target In an M cross n integer matrix, the matrix has following properties. Integer in each rows are sorted from left to right. Integer in each columns are sorted in the ascending order from top to bottom. Okay, so we have a sorted matrix, right? Row sorted and column sorted, and we have to apply binary. Of course, if it is asking for efficient algorithm, we have to apply for binary search. Now, if I see the constraint, now you see it is like m and n is less than equals to 300, right? And we just have to return whether true or false. So I can iterate over each element and check. So that will be like 300 square. So it is like 9 into 10 to the power 4, and that will be submitted, right? There will be no issue at all. So, for example, let me show you if what I'm saying. So I can say simply like um um something like arrays dot stream of matrix, and then I have to flat map it. Um, I don't exactly remember the syntax. I am used to have so much ID, right? So x, I will say arrays dot stream of x, and then I'm gonna say filter um each item and check if a is equals to target or not, and then I gonna say like count is greater than equals to maybe 1L. Will this work? Let's see. Okay, what it says. Cannot infer type. Sorry, what is saying? Flat map. It says mismatch. Bad lambda expression. I don't exactly remember the flat map syntax actually. Uh, in IDE we generally I don't use it, so that's why. Flat map. I think it takes it's a function basically, a function that returns something. Or do I just need to say like arrays dot stream maybe? I'm not sure. Let's see. No, 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 no. Um, hmm, flat map. What is the syntax for this one? Arrays dot stream. It says invalid method reference. Okay, so if I'm saying in a stream of matrix, so this will create me a stream of arrays, and then, guys, I don't exactly able to remember, right? So let's do something like this. Um, maybe I can just I would just want to show you like this will pass the test cases, right? Because 300 and we can iterate over each element. So something like for int m of matrix, I can just say for int a of m, if a equals to target, I can say return true, else um return false. Yeah, false, right? And if I try to run it, so same thing I was trying to achieve using stream. I actually forgot the what we say flat map syntax. You can check on the internet, but let's drop it. So yeah, we are able to solve this, but of course, this is not the approach the interviewer will want to. So let's try. The first thing I do is let's try to get the dimension of our matrix, which is matrix zero dot length length. Okay, just give me a 1 second. Let me my charger. Yeah, so since the both the columns and array are sorted now, we're gonna apply binary search. And how I'm gonna apply, let's see, if and I have not sure about it, but yeah, we will see. Okay, I added my charger. Okay, so what's the idea? Since the arrays are both row and column wise sorted now. The very first thing I would do is try to find what column it can my target can exist, right? So that's I think that's the first thing. So we have to apply binary search two times, right? So that's correct. So what I'm thinking now, um, so for example here the target is 5. So does my 5 exist in first row? Does it exist in second row? Yes. So I think first we need to find which row it can exist, and then we're gonna apply binary search to get the exact whether it exists or not in that row, right? So that's the idea. So in my previous video, if you don't know, I have solved one binary search and answer based problem, right? So there I explain binary search using predicate logic that I follow. But here simple binary tricks also work. So yeah. So let's first try to find out the column, right? Sorry, the row in which my target might exist. So what's the idea? It can either exist in left, right, left is equals to 0, and then right is equals to um, m minus 1, right? Maybe I can say m. Uh, like if does not exist, then I'm gonna return. But I think m minus 1 will work. And then I'm gonna say while left is less than right, typical binary search. Mid left plus right minus left divided by 2, and then let's check if mid. Uh, I think what we have to do is we have to find like the row where this target might exist. Okay, so maybe I have to compare not just the first element, also with the last element, right? Mm-hmm. But the idea, the first idea is I think clear. We have to find the row, right? So how we gonna apply? Of course, this is a binary. Only thing we can do in a searching based question is a binary search to make it more efficient. How I'm going to apply binary search to find the row? That's the question. So, Um, here, no, I'm basically mid is what? Mid is like my current row I can check, right? So I can check like if uh, matrix of mid row comma 0 element is greater than equals to target and matrix of mid last element, right, which is n minus 1 is less than equals to target, right? So if it is, right is equals to mid, else left is equals to mid plus 1. So my left will contain the very first index where this condition gets true, right? So this is the idea. And yeah, so my left will be the row that we wanted to explore, correct? So let's, I will call it left as a target row maybe. So TR I'm calling it. Now let's apply again binary search in this row now. Do we have this target exist or not? Right. So I'm gonna again say left is equals to 0. Now right is equals to n minus 1 because now we're gonna check in the column. And then I'm gonna say again while left is less than right, int mid left plus right minus left divided by 2. And if um okay, so we have the row, so matrix, we have the row already the tr comma mid is greater than equals to target, right is equal to mid, else left is equal to mid plus 1. And then here I'm gonna just say return matrix. tr, oopsie, tr, comma, left equals to target. Yeah, yeah, this is the idea, guys. So first, I found out which row it can exist using the first binary search, and then in the second binary search, I did is I try to find whether that number exists in that row or not, right? So I can just do like that number equals to target or not. So let's try running it. Let's see. Do we have any compile time error or anything? So we have one error, and we have here I should use semicolon, not comma. Yeah, let's go again. Okay, so for 5, I'm getting false. That's bad. Right, that's incorrect. Uh, why? Because let's see what the row I'm getting from the first method, which is left. I'm getting the index as a 4. 0, 1, 2, 3, 4. Why? Okay, because here I messed up the condition. Okay, I have to say something like target is greater than equals to, right? Target is greater than equals to this, and target is less than equals to matrix made minus 1, right? So let's try again. I messed up the conditions basically. And now it's again incorrect because now I'm getting 0. I think why this is happening is because um so when I come at this row, not checking, for checking, I'm saying, do we have 5 greater than 2? Yes. Do we have 5 less than 19? Yes. So this is the true. Now I'm trying to find again, do we have anything before this also? So do we have, right? So this is the only problem with my binary search. So what I have to do now, I have to check one thing. So here I will say my matrix of um left comma 0 is greater than equals to target, and then not again I'm doing same mistake. Target is greater than equals to the the current row that we have identified or not. So and target is less than equals to matrix of left n minus 1 question mark. If it is, then left. Otherwise, it should be left plus 1. Correct. Let's try again. Okay, now again getting false. Um, so now what's the issue here? Let me again print tr and left. So I'm getting 0, 0. That's wrong, right? Uh, so target is greater than and target is less. Okay, I think, yeah, that's correct. It can exist here also. Hmm. Am I missing anything? I don't think then this logic will work. Yeah, I just identify like it now. Yeah, pipe can exist here also, right? Pipe can exist here also. Even pipe can exist here also. So these are all existing based on my condition. Okay, so we have to modify our check. Oh, what we can check? Um, mhm. So I think our first logic is here. We have to count the very first row where it can exist. But how we can eliminate that it can exist in maybe 1 to 15, the first row and the third row? And I don't know how much we have to optimize this problem also. Okay, so what we can do? Mm, let me try to understand. So we have each row sorted in ascending order from left to right. Each column are sorted in ascending order from top to bottom. Pretty sure that we have to work with this, but I don't think this single condition will work. No, it will not. So just for the reference, let me see what's the fourth question. Okay, so we have to implement LRU. This is very good question. Okay, we will come back on that one. Efficient algorithm, target, we have integer matrix. Can I do this simultaneously, like when I'm finding this mid and then try to find out whether that exists or not? But if it does not exist, then where should I go? Should I go below? Should I go above? That's how I can how light determine. That's the problem. Hmm. So we have each row sorted in ascending from left to right. Okay. What what things we can do now? Hmm. Oh, okay, let's say if I calculate a mid for from this row, I come to here, right? So 3 and 22, this row, and then I try to find 5. Do we have 5 here? We don't have 5 here. This means, um, do we have to compare this last and this first and last element also? Um, uh, not sure. How we gonna do this? Okay. Uh, 1, 4, 7, 11, 15. So this is the false condition. No, we will come back on later. How I'm going to determine the row? Or should I determine the column? But that will be the same thing, right? Whether you are going through column or row by searching. So I go to the row 3 and 22, and it might exist. The 5 is between 3 and 22, so it might exist. So do I have to check at the same time or not? That's the question. And if it is exist, then very good. If it does not, should I go a row below or should I go row above? And okay, so something one idea is let's try one thing. Okay, I'm the very first time my first binary search, I'm getting this mid and I'm gonna check something like this. Let me remove this one. If I can check if matrix No. If my target is greater than equals to matrix of mid zero, this means that this will make sure my answer will exist either in that row or a row below, right? Else, if target is less than, let's say we are at this row and my target is 7, so I should try to find my answer below. So which is like a right is equals to mid. Now here we have can have multiple cases, right? Um, so for example, my target is true for 3, it is true for 2, and it is true for 1. It is true for everything. So how I'm going to determine which row it should, let's say it comes at the second row and it will be able to find, let's say it comes to the third row, right? If I apply a binary search on the third row, I will get it is not able to find 5. Then it should try from here. Left is less than right. Okay, so can we do maybe, not sure. For 2, 5, how we can determine when we should go above after finding the rows, like all the potential matches? Hmm, the first logic. So could I apply one more binary search here? If I apply one more binary search here, hmm, so 2 plus, do I have to apply 2 to binary search, or like log n plus n is fine? Uh-huh. I'm not sure, guys, how we're gonna solve this. Using binary search. Do I have to binary search at all? Because the constraint says 300, and it doesn't say like whether we can solve this problem in a binary search way or not. Like whether we should solve this. I mean, if I just have to use the constraint, maybe I can iterate maybe row by row and then try to check like each row. Hmm. So maybe start from the 0th row and the last column, and then try to find out like whether this number is in the last or not. I don't think, guys, we can solve this using this log n time. Log n plus log n. 2 log n is, I don't think this is feasible and it's not possible. I mean, how? I mean, this is giving me a large sample space even after the binary search, and it doesn't make sense to me actually. Okay, we can solve this in a log n time. No, think the max we can go is a linear. Maybe basically linear means iterate over each element, max to max. Um, yeah, this is not possible. I don't think binary search will be possible for this problem. So I will search on the internet, guys, later after this section, and let's see if we can solve this problem using log n time or not. I don't think log n is possible, but to be honest. Right, so let's go to the next question, fourth question. Okay. So this is a LRU cache problem, and I think this has been asked in many companies' question. Like this is kind of like famous question. LRU, LFU, then designing different system based. So it's a system design based question. So it says like design a data structure that follow the constraint of LRU. LRU capacity you can pass. So positive size with capacity. Okay. Then get return the key if the key exists. Otherwise return -1. Then you're gonna put the key and value. Update the value of the key if key exists. Otherwise add the key value pair to the cache. And if the number of key exceeds the capacity from this operation, evict the least recently used key. The function gets and put must run in a constant time. So that this is the thing, guys, right? Otherwise, it will be very easy to implement. But we have to make sure the get and put operations runs in a constant time. Otherwise, you can simply use hash map, right? And then seeing the capacity, it's like 3000, and then 2 to the power 2 into 10 to the power 5 calls are gonna make. And if you use simple hash map, even simple hash map, it we will be able to pass this test cases for this question. And I can show you that. Let's try first the brute force one, and then maybe we can check what things we can optimize. So it basically use a linked list kind of thing. So linked list plus hash map. I don't exactly remember the algorithm, but I will try to write it out and maybe it will come with time to me. Yeah, for now, let's try a simple hash map based approach just to solve this problem. And then we can try to optimize it using linked list. So what it says like we're gonna put some value. So one, one, two, two, and then we're gonna get some value. And if the value doesn't exist, we're gonna return -1. And then we have to evict the list recently used after this capacity, after it reaches the capacity. So I don't know has that will work or not. Maybe because we we need to make sure that our caches is getting cleared after the capacity operations, right? We have to make sure whenever we reach the capacity and we are trying to add any more thing, we should remove that item. So what's the idea? Let's go through understanding this problem. Okay, so I think in Java we have already one implementation for LRU. So in the questions where you need to LRU, you can use I think linked hash map or something. There is a one implementation, and I don't exactly remember the class name, but it was a big class name. So something linked and hash map something. I don't exactly remember, but yeah, there is in Java we already has one implementation. So in your application, like production application, you should use that. But for this one, we have to implement our own. So okay, so what I'm gonna do? So we need to make sure we are tracking the capacity. That's the first thing. So let's make it class variable, right? And I'm gonna say this dot capacity equals to capacity. So yeah, and maybe you can make this private encapsulation, right? Um, yeah. Now it says get key. So, okay, we have to somehow store key value pairs, right? So I think for this we have hash map, right? And I'm not sure, guys. I'm solving this random, and I have solved LRU cache like 1 year before. I don't exactly remember, so I don't know the perfect syntax and all. But yeah, we will figure out. So and now we need this get operations, right? So for get operation, I think map will be fine. See, and let's initialize our map here. See, I haven't named it map, and you can say like this dot map new hash map, right? Now what? Let's read the questions one more time. So this is the capacity. Get will return if the key exists, right? So you can simply say if map dot contains key, uh, key return map dot get. Or simply even I can use map dot get or default method that is more equivalent to writing all those conditions. So if it exists, give me the map dot get key. If it does not, return -1. So this is what the question says, right? The get method. Now all those logics we have to think about this put. Okay, so let's see. Update the value of the key if the key exists, right? Otherwise, add the key value pair to the cache. And if the number of keys exceed the capacity from the operation, evict the least recently used key. So if you see here, so we're gonna add some numbers, add some keys one by one, right? So let's say A and then B and then C. So what's the least recently used will be the A, right? Because it has been used the very first time. You understand, no? Like for example, I'm saying here, if you see, we have something called, let's say we use A, then we use B, then use B again, and then we're gonna use C. So what's the least recently used? Which is the yeah, least recently used is A, right? Now let's say if it is C, and then again we have a, so we have to remove this A, and now what is the least recently used? Now recently is B, right? So if I have B, so I have to remove this B from here, this B from here, and then what is the least recently used? C, right? So this is the idea. Let me again explain how this is working. So let's say we already we have some cache already with value A, B, C, and D, right? And our capacity is let's say 4. Um, Let me remove this one. Our capacity is 4. Now I have one more value comes as a E, right? Let's say E. So we have to remove this A, right? We have to remove this A, and then I can use this E. Now let's say some other value comes F, which is the least recently used, the very first one, right? So we have removed B, and I'm gonna add F, correct? Now let's say for the same key, I'm saying for the same key we have a value that is already exist here. No, no, I'm saying like this. So let's say again we get this E. Now again we get E, right? Something like E. So we have to somehow remove this E, right? We have to remove this E and make this E to come here, right? Now it is the least recently used. So you understand the idea, na core idea, and that's why it is not as simple. We cannot just implement it using map of integer and integer. That this will not work. So let me comment this out. So what's the idea? The idea is to use a linked list. Why? You can use a double linked list, but I think I'm gonna use a single linked list. How? Let's say we have some keys and value inserted as like this. So we have a node A and it has value associated as 1. Then we get a node B, it has some value associated as a 2. And then we have some node each has a value of 3. Not like this. 2. This and then so let's say our capacity is 3. Yeah, for this one. Our capacity is 3 and we have some new value. Maybe for B. For B, I get again this put method. I'm getting for B, please make it 10. Something like this. So what needs to be done? I have to remove this B now, right? First, I have to move this B to here, right? Here. B and then 10 and I have to somehow remove this B. So I hope this is clear. Now, how efficiently we going to remove this B, that will determine the our algorithm, and we have to solve this into the constant time. If it is either in the left side or the right side, it is pretty easier to remove. But when the cache value exists in between we have to remove. So that's why so if I somehow store this node location, right? This node location where it is, and maybe its previous value and the next value, then I'm able to solve this problem in the constant time, right? So then what I'm gonna do is, since I exactly know the location of this node, so I know this is the location. So I just have to change this pointer in a linked list to this pointer, right? And it will work in a constant time. So that's the, I think, I hope this is clear. And it is also like 10%, only 50-60% clear to me also. But yeah, I think you get the idea, right? So what needs to be done here? I need to create a node, let's say, and what the node will not what the node will contain. Let's say mm, it contain a key, it contain a value, and I'm gonna say key int value comes from the constructor, and then I can say this dot key this dot val, right? So and each node is gonna have a pointer to next. Each node gonna have pointer to previous. This is now getting a bit tricky, guys. I hope you are with me on this one. Uh, Next is equal to now simple linked list implementation, right? So this is my node. I can call it like list node. LeetCode generally uses list code, but I think this is fine. Key value and next in the previous. Yeah, I think this is correct. So what I'm gonna do is here I'm gonna create two node head, right, and node tail. Okay, just this is for the reference purpose. Let's make private, and private this one also. Oops, private. Yep. And in the constructor, I can say head is equals to new node. Its value gonna be 0, 0. It doesn't matter. And then tail is equal to new node. Oops, 0, 0. Right. And let's create the connection between them, right? So I'm thinking something about like this. So this is my head. It's gonna have this pointer and of course this pointer. And something like this I'm creating. And then in the between I'm gonna create all my nodes, right? The key and value and all. So this is the idea. Um, Let me hide this. And yeah. So what I'm gonna do is hit next equal to um head next is going to tail, right? And tail previous equal to head, right? We created those conditions. So now we have something like this. Okay. I know it is a bit tricky. It's tricky even for me, and I'm not sure. Not 100% sure whether I'm going correct or not. But yeah, we will see. Okay. Now what I'm gonna do is, so we have this get method for this key. So maybe for this key, I'm gonna store the node, not the value, because this node will contains the value. Hmm. So do I have do we need this key? I'm not sure. And let it be. So let's try to create from this one to from map integer to map node, right? And then if here map dot getter default key, so I have to write something like this. This will not work, right? If map map doesn't contain key key, we're gonna return -1, right? Otherwise, what we're gonna return? We're gonna return map dot set key dot add. I hope this is clear. I just changed the value from integer to node, right? And yeah, I think this is it. Now here this thing will get funny. Should I write some helper method here for adding add to head or add to tail or something like that? I'm not sure. Let's see. We will see. So what's the first thing? So this is the map where we're gonna store all of our values. So if map dot size, no, 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 no. I'm gonna say like something like this. If map dot contains key, then we have to update it, right? We don't need to add linked list or anything like that. No, no, I think we still need linked list, but if it is already exist, then what we have to do? Else if it is not and map dot size equals to capacity, then what we have to do? And then last case, what we have to do? If this is coming for the first time and map doesn't seen is earlier and map size is also less than capacity, then what we have to do? So I think this is the easiest one when the this any put operation coming for the first time, kind of like you can think of. So what things we need to do? Hmm. So first we need to create a node, right? So let's create that node, new node. What will be the value? Value will be value. I'm gonna put it into the map.put key comma node, and we have to insert this node um at the like last, right? So add last method we need, right? For example, here, let me show you. Let me see this one. Um, Currently we have a structure like this, right? And we have one value come, so we have to add that value something in the between head and tail, right? So let's do that. So what we're gonna need, I can just choose the reference of a tail. I can just say tail. Um, so I will create one node, maybe something like this. Let me show you. I will create my node. Let's call it x. I will set x dot previous head and x dot next tail, and then tail dot previous x, right? And this is what I will need to create a doubly linked list for this one. So, um, so should I extract this method into a separate utility method? Because what we are doing is we are just inserting, um, we are just inserting a node just before the tail, right? Um, just head and tail will work. I'm not sure. Not sure about it. Because we might have value like this. So currently in this scenario we have something like this head and some let's say some space and then tail. Let's say something value comes here, some new value comes here x and I have added x like this. That's fine. I can do the linking. Head next is equals to x, x previous is equals to head, and then tail previous is equals to x. But what if another values come, right? If another values come, let's say maybe p or maybe x or something, q something. So now I have to arrange this value based on now this x will be my head, right? Not I should not do it like this. X something is equals to this. So this is I think this is the case where we don't have any value at all. Okay, guys, this is getting tricky. But we have time. We have 55 minutes. So yeah, we can do that. So how I'm gonna track of hmm. So what should be like my head or what should be my tail, something like that. So this is the two nodes I created, dummy head and dummy tail. Should I also create head or tail? So initially they point head and tail, and whenever I add something, my head become head next, something like that, and tail become tail ka previous. So this is my head and this is my tail, and then I need to add one more item. How I'm going to do this? Mm, okay. So map. Okay, this is good. I have to think about these conditions. Is it enough? Mm, okay. Let's do something like we always need to create new node. That's for sure in the put operation. So this is I'm 100% sure. Now what? I'm saying let's check if map dot size equals to zero. No, something like this. If map dot size equals to zero, I can just say um map dot put key to node and then our head dot next equals to node, node dot previous equals to head, and then tail dot previous is equals to node. So this is fine. This is perfectly fine. We have something like this. We have something like this where this is happening, and you can think of this row as a double pointer, right? We can go forward and backward, but so this is fine. So what will be the next easy condition we can tackle? Next easy condition is if some values come and we are still in our capacity, right? And it does not exist in the map, in our map, yes. So for example, let's say A, something comes as a key with a value A, then how I can do this linking? Because I need the reference, right, for this X to do the reference from this thing. Uh, Actually, no, no, no. So this is our current syntax, right? If you see here, this is our current syntax. Head pointing to the X, the very first key, and the X pointing to the tail. Now the very next element comes. I just need this tail reference to use, right? So let's say if something comes as a S, I can say now uh, tail dot previous. that will be this node, right? I can say tail dot previous dot next equals to s, right? And then s dot previous equals to x, and s dot next is equals to no, and then tail dot previous is equals to s. We can do that, but can I write it in a better way? Maybe I should write a utility method instead of doing this every time. Add head, add tail, maybe something like that. Can I write? Let me try, guys. So, okay. Let me write public void add tail. Right. I'm gonna get a value. Maybe I can say something like I'm gonna get a value. I'm gonna get a reference of a tail, which is already is a class level instance variable. So it's going to be accessed here also. So I'm gonna create no new node with value, right? And now we have to do this linking. So what I'm gonna say is previous is equals to tail dot previous, correct? So I'm able to basically access this x now, okay? And then I will say x dot next is equal to node dot previous equals to x, and then node dot next equals to tail, and tail dot previous is equals to node, right? So this is we are doing basically this linking now. Uh, we have something like this initially. So we have head, we have x, and we have a tail, and now let's say we're inserting s. So I'm just accessing this x from my tail, and I'm doing this x dot next is equal to s dot previous is equal to x, s dot next is equal to tail, and then tail dot previous is equal to s. Right? Yeah, we will be able to do this. That's pretty cool. This is add tail method. So, hmm, I can remove this one. Okay, so this utility method will definitely help. Now the problem is when we are at capacity, then what we have to do? So let's say this is we already did this linking. No, let's see something like something like this. If map dot contains key, map dot contains key, then what we have to do? This is I think this should we should handle this the very first thing. So maybe something like this. So you see here, head is pointing to the x is pointing to the s is pointing to the tail. What we got a new value of a x, right? So we have to remove this x first, right? And I have to add this x to the tail, right? Because now it is a new value. So let's write one more utility method for remove. Void remove node, or maybe I can get a key and then I can extract the value. Uh, node from dot get. So this is the node, and we have to remove this node. I can access the previous of this as a node dot previous. I can access the next of this node dot next. Now I just have to do it previous dot next is equal to previous dot next is equals to next, and next dot previous is equal to previous. Yeah, I think this will work. So what I'm doing is, let's say I wanted to remove this x, maybe and this s. So I will go to the previous. So this is my previous. I'm saying previous dot next. So this I'm removing this pointer and this is going to pointer to the next, and the next dot previous No, not previous dot next. No, next dot previous. Next dot previous is equals to previous. Oopsie. Yeah. Previous dot next is equals to next, and next dot previous is equals to previous. Next dot previous pointer will not pointing to this previous. And this will be dereference, so GBM will remove. So we don't have to put null or anything. Yeah, I think this is it. So, okay, so we remove it and then we will add it. Okay. If map that contains key, what we have to do is we call the remove method on key. Okay. And then I'm going to add a method and then I'm going to pass a value. And of course, I also need to pass the key, right? Key is also we need to pass to add it into the map, right? So something like this. Map dot put key comma node. And here I'm saying first remove the key and then add at the tail. Add tail method, not add. Mhm. If map dot contains key, else if capacity equals to map dot size, then we have to remove the first element, right? So this will be the first element that we need to remove. So let's write method for also public void remove first. So how I can remove this element? Maybe I just need to move this head to the head dot next, right? My head pointer, or maybe head dot next is equals to x dot next, something like this. So like current is equals to head dot next, and then I'm gonna say like sorry, current is head dot next. Uh, or previous. Now how should I remove? I just need to remove the first head element, right? So this, so there will be edge from this, there will be edge from this. Can I just say like head is equals to head connect? Will it work? I think so. And we are not caring about anything, so I think it should work. Let's do something like head is equals to head connect. I think this will remove the very first element. So I'm saying something like this. Let's say we have something like A, B, C. This is my head. No, not like this. Head equals to this. Then I have to remove this. I can just move my head from this point. Now this is my new head. Right. So this is kind of like remove. And then I'm gonna say I have to extract the value also. And um no node node is equals to head dot next. And now I have to get the keys, right? Whatever keys inside of this node. So I can say map dot remove node dot key. And then head is equals to head connects node dot key, and then head is equals to head connect. Yeah, I think this is it. But one thing we need to make sure is this node, we gonna create a node using key and value, not just key, right? Key here also. Yeah, so whenever we reach at the capacity, I'm gonna say remove first. Yeah, this is my method. And then add tail key value if it is a capacity. Else what we need to do? Um, else I think we just need to call add tail method key value. Yeah, I think this is it. I know there will be many compile time errors, I'm pretty sure. But yeah, I think you get the idea, right? So let me remove clean up this code. So we have this node. Let me see key value next previous and all. We have remove post, remove, and then add tail and put method. Yeah, let me run it. I know it there will be issue. Yeah. Okay. So how many errors are there first? Let's see. Okay, I think line number 36. What is 36? Public void add tail int key and then int value. Okay, here I'm getting what is this egg? Hmm. So add tail method. Okay, we created a node very well. We put this node into the map. We get the previous tail dot previous, and I should say previous dot next. Previous dot next is equals to node dot previous equals to previous, and then node dot next tail and tail dot previous node. Yeah, this is it. Let's see. Okay, again, it is next, not next. And do we have anything else? No. Let's see. Okay. Okay. So null, 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 one null, and then I'm getting two. That's minus one, three, four. That's correct. But here null, 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 three null, then one, then null, and then it should be minus. So I don't know where we what we messed up. It will take time to debug, guys. Right? Let's see. Let me copy this output and hide this console so it will be visible for you also. Right. Let's see. Okay, so LRU cache put put is fine, get is fine. No, put put put, and then get is fine. Then put and then this get. Hmm. LRU cache capacity two, right? The 1122, then 133, then 244. Okay. Node head, we created node, we created capacity, and okay, we are not checking with the capacity or something like that. In capacity, uh, LRU cache, let me have this that capacity is equals to capacity, that's fine. Okay, now put method, we are creating a node, right? We don't need to. This map dot contains key. So I'm hoping that we always maintain our capacity. So this should run the very first thing. If map dot contains key, we already have a key. We're gonna remove that key from here. Okay, so we are not removing the map value from map here in this remove method, right? Hmm. After getting this node, we should remove this also. What is this remove method was doing? Okay, we are we are removing any element. It can be in middle or anywhere. Very well. Node map dot get key. So I extracted the node, and yeah, we should remove that now from the map, which is like map dot remove key, and then previous next. Okay, let's try again. Okay, so we have null, one null, and then again two. Oh my god. So basically it should be empty, but we have some value. I don't know why. So one, two, then one, then three. Okay, then I'm getting two. Yeah, but two should be two now. If the number of key exceeds the capacity from the operation, evict the listen presently used. Guys, I'm not understanding. Like if see here, one. Okay, even the get operations we have to update our cache. Yeah, that's the main motto, na guys. Sorry. So what I'm doing is whenever I'm putting, I'm updating the cache. But whenever I'm getting, we need to update the cache. So what we need to do, we have to call this method again. Remove the key and add. So it can be something like int answer or maybe result equals to this, and I will call this method again just to refresh my key. I will remove that item from the map and the linked list, and I'm gonna add that value again. And then again I have to put it also. No, I think add till will put it. Yep, yep. Add till will put it. Um, remove key, okay, and then add till will put it value, key and value. But we have to get the key. Um, we have to get the value, right? Result. To pass result, not value. Go and refresh the key and again add this value. Again, the same thing. Okay, let me rerun this. Okay, we have missed the return step. We return also. No? Okay, now it's the null, 1 null, -1, null, -1, 3, and 4. I'm hoping if it get accepted now, I will be very happy with me. I'm to be honest because yeah, it is like a very proud moment. Let's try submitting it. Okay, guys. Thank you so much for watching. So we are able to solve all those four questions in like 1 hour, right? I think this takes like 1 hour and 30 minutes. But everything we did this one for this creation of the doubly linked list and the map and all from the scratch. So I hope you could get the good idea about it. Let me know what you think about this problem. And yeah, I can, if you want my submissions, I can share it in the GitHub maybe. But I think you will find much better explanation than me on the internet. But yeah, I hope you like it. Yeah, drop a like, comment, and let me know what you think about this one. Right. Thank you so much, guys.